One of the most common magnitudes used in chemistry is concentration. We have talked about solute and solvent, and concentration is right at the core of measuring how much solid you have per unit of solvent. So concentration is typically a ratio of solute over solvent, and solute may come in different units, in mass, in grams, and the solvent as well. So we will explore the different units that we will use in this semester. But again, the take-home message of concentration is that it's a ratio. If it's a ratio, it means it does not depend on the quantity of solution that we have. So just to give you an example here, we are trying to identify or rank in this case in order of increasing concentration. So solute are the pink dots, and solvent, the quantity of solvent is given here. Okay, so for A, if we count, how many dots do we have? This is 3, 6, 9, and 12 over 500 milliliters. For B, you have 6 dots over 500 milliliters. C, you have 3 and 3 and 2. This is 8 dots over 500 milliliters. And then D, you have 6 over 250 milliliters. For E, you have 3 over 250 milliliters. And finally, F, you have, how many is that? That's 8 over 250. So we're trying to understand which one has the highest number. Okay, so you could just get a calculator and find which one has the highest fraction, and you will see that F is the highest of all. Okay, what you could do that is to make it into the common denominator. This will be 12 over 500, this will be 6 over 500, this will be 16 over 500. So 16 is the largest number. It'll be followed by there's 2 with 12, so A and D have the same number, followed by C, and finally you have B that is equal to E. Okay, a very simple calculation, but at least it gives you the sense that it's not a question of quantity of solute, is how much solid you have over solvent. So how many units, or what kind of units are we going to deal with in this course? Well, the most popular one, and it's very, very important that you can manipulate it, is molarity. Molarity is moles over liter, and I cannot I cannot exaggerate when I say that it is one of the most important magnitudes throughout chemistry. So you really need to make sure you can manipulate it and understand it and work with it. Okay. There are other less important, but nevertheless we're going to talk about, which is the parts by mass and parts by volume, and molality, that is less common, but it's very close to molarity by name and by formula, because notice that volume of solution and mass of solution, if it's water and the density is the same, sometimes molality and molarity are approximately the same. There is a very important distinction, is that some concentrations are independent of temperature, and that's important when you have a specific concentration or a specific solution that is studied at different temperatures. You want to make sure that that concentration does not change temperature. As you will know, volume will change with temperature. However, mass does not change with temperature. So everything that has mass or moles in the denominator, that will not depend on the temperature. However, if you have volume, that will change on the temperature. In this course, again, because we will deal mostly with solutions at room temperature, we are very happy with molarity, and that's the unit that we will be using the most.